and welcome to Real TV. I'm Luke Faulkner, and this is Mrs. Flemingos from the Port Huron Area School District.
Yep.
All right, Mrs. Flemingos, I have a couple questions for you.
Sure.
Now, about a week ago, we did a science fair. What night was that?
Tuesday, January the 11th, we had a family science night.
Now, what was the purpose of this?
The purpose of family science night is to help the 4th and 5th grade students focus on preparing to take the MEP science test in 5th grade. This year we performed the science experiment that involved pitch that they did last year for 1999. And it gives the children an opportunity to work with their parents, to do the experiment, write it down in a journal. They get some experience and their parents begin to understand what's expected of their student.
Now, can you explain what exactly was the experiment that you did?
Sure. The state gave us this experiment last year, and they said we could use it this year. And what we did was we took a drinking straw that was 19.5 centimeters long, and we marked it in 4 places at 3, 6, 9, and 12 centimeters. At the other end, we cut the end of the straw into a V shape, essentially to make a reed. And then what we did was we blew through the straw and produced a sound. And then we cut the straw at the 3 centimeter line, made it 3 centimeters shorter, and blew again. Then we did it at the 6, and the 9, and the 12, and as we cut, the children began to understand that the shorter the straw, the higher the pitch, and we recorded that in our science journals.
All right, now, what was the hypothesis that the kids had before you started?
Well, the hypothesis came from the question, and the question said, can a drinking straw be altered to produce a sound? And from that, the students made their own hypothesis, and we tried to have a working hypothesis for the group, because a lot of the kids have prior knowledge about this. Obviously, kids have blown in drinking straws before, and they have some idea what's going on. But we like the students to each develop their own hypothesis, but we had a working hypothesis for the group that said, yes, they felt that they could produce a sound, and that as we cut the straw shorter, the sound would get higher. Very, very few children thought that it would get lower as we made it shorter. And of course, that's why you do the experiment, to prove your hypothesis anyway.
Now, you can do these with anything at home. What are the materials that you need to do this?
What we needed was a drinking straw that was, as I said, 19.5 centimeters, a marker, so you can mark your straw. Probably a good idea if you have a permanent marker, simply because it won't come off on your hands. A metric ruler and a pair of scissors that will cut the plastic straw. It's a really easy, non-difficult experiment that the kids should be able to do, and they've probably done it. The hardest thing is getting the reed end to work, and once they cut it in the V, what we have come to find out is you really have to blow in the straw for a little while, get some moisture in there like you do a reed. Once there's moisture in the straw, it will start to make a sound, but it's something that they can do at home without any difficulty. The only thing I would suggest is that they have a straw that doesn't have the flexy stuff in it. That distorts the sound.
Now, how long does it take to usually do this experiment?
Well, we rushed it last week, so what you taped was hurried, because we needed to keep to a time frame of about an hour from beginning to end. But if you were going to do this, when we did it last year in the classroom, it probably took us 45 minutes to really do the experiment and do it well and talk about it, and then add some time for follow-up. We discuss as we do an experiment. After you do the hypothesis, you have to go back and see if your conclusion matches your hypothesis. We need to come up with reasons why you came to that conclusion, and then the big one is margins for error. What did I do that could have made this assignment come out wrong, or this experiment come out wrong?
Now, did you have any students that couldn't get the straw to work?
No, but the grown-ups had trouble. No, actually, that happened last year a little bit. But again, the trick was, tell them, you've got to get some moisture in the straw, and as you blow through it, that's going to happen. Because the first thing is they all do it, and they go, I don't get it, it can't happen, that's not working. They just need to have a little patience, and you kind of have to tinker with it a little bit. Sometimes you have to flatten the end of the straw, and you can use your fingernail and flatten it on the table. If that doesn't work, you can run this blunt end of the scissors over it, or you can do what my dentist would not approve of, and I've been known to bite on it a little bit. But once you get it flat and it's moist, it'll work.
All right. Now, when we were there, I saw a kid. It was sitting next to me. He attached a bunch of straws to it, And it sounded like a big horn.
I know who that child was, actually. I saw that. And, well, that proves the hypothesis, because the shorter the straw, the higher the pitch, the longer the straw, the deeper the tone is going to be, or the deeper the pitch. So that was a really good experiment, and somebody always comes up with that, but that happened to be a teacher's son, and he had come with his mom, and so I was kind of watching him out of the corner of my eye. He was obviously having a good time with it.
Yeah. Now, after you were done with this, the next day, did you have students in the cafeteria doing that?
You know, I didn't get any input from the lunch ladies, but last year when I did the experiment, I told the students when we were all done to please take their musical instruments home. Put them in your pocket, stick them in your backpack, take them home. Your parents will really enjoy them.
Yeah, you said that this time,
yeah,
too.
because we didn't want to go through that again. It's a common thing, and yeah, they're going to do it. I think the fun part was that it was something that they've done before, and it is fun. They like making all this noise, and it really was a good time. Some of them have not been quite as exciting, if you will. So that was a good time for them, and if they want to go and practice it a little bit, it's not going to hurt anything.
Now, did you get any complaints from the parents about it? Like the kids came home and they just started squealing it?
No, actually. I'm really glad, but I would certainly have been happy to refer their questions to the State Department of Education who created this experiment. No problem.
Now, you might not know this, but how exactly did they come up with the experiment? Did somebody just cut a straw and decide to blow into it, or did a kid make it up? Or
I don't think children make it up. I do have some idea how this works. There is a committee of teachers that work together to create the experiments, and there's got to be some real, actually, structured criteria for this to happen, because every fifth grader in the state of Michigan did that experiment last year, every single one. So you have to find something that is simple, that can be shipped easily, and that doesn't cost a lot of money, because the State Department of Education is the one mailing these things out. So they're not going to mail us wonderful, marvelous, expensive experiments. So they had to look at something that's cost efficient, that will be easy for the students to do and easy for them to ship, and that's going to have enough scientific background in it that they're going to be able to gather enough data for it to be a worthwhile experiment. But I think cost is always going to be a factor, because it's got to be something inexpensive. Last year they sent us the straws, the little paper rulers, those little metric rulers that we used that night, and we had to supply our own scissors, which every school would have, and the markers to mark the straw. That was not a big deal. But you've got to think that there are going to be school districts that are much poorer than others. I mean, obviously, what you could supply in a wealthy district for an experiment would be different than in a school, an inner city school. So it has to be something that everybody can do, and it's equitable. So they don't ask the schools to provide a lot for that very reason. It's got to be something that the school district can support as well. So there's no expensive microscopes or anything. It doesn't have to be that kind of a scientific level for it to be useful.
Now, how many students did you get this year than you had more? Did you have more this year or last year?
Actually, Luke, we had about the same amount of students, and that kind of surprised me. This year, the accurate count was 119 people, and that didn't count like the babies that went to the child care, because we do provide child care during the event so that the older sibling can focus on what the science is with their parents. Last year, our science experiment that we did involved water, and that's messy enough with fifth graders. We didn't need to have babies in it. And it's fine. They go down and we have adults doing it, and that's fine, doing the child care, and then they bring them back. But we had 119 people. Last year we had a horrible snowstorm that started as the buses were pulling out, and it snowed like crazy, and I was terrified that I was going to have this experiment that night and I was going to be there all by myself. And we had about 100, and I think we had about 120 people last year. So for me to look at it, I'd have to say maybe our interest is waning. This is our 4th year to do family science. Maybe what we need to do is look at it and consider maybe we want to do something different. This year we made sure that we had a presentation on science fair, because Kroll has always had a really extensive...
Yeah, I used to go into it every single year when I was here.
Well, then you know. And they got up and they gave the the students and the parents some ideas on how to get their kids going for science fair. And we're looking at all kinds of possibilities. Maybe we want to shift our focus away from preparing for the meet next year and shift it to science fair. Maybe we want to combine them. I don't know. We're working on it. But our numbers were stable. We didn't see any increase, but we didn't see a decrease either.
Now, what about extra credit? Did they get extra credit there, or was this just for fun?
No, this was just for fun, but we bribed them.
You bribed?
When we start talking this up with the students, I sent home the registration form and a sheet on the back with some real cute graphics. The night, they returned that the night of science fair, and on it they were asked to list 3 occupations that would use science and why. And when they did, they were met at the front door by registration. They were handed a gift. It was a quill pencil for anybody that came and turned the sheet in. Then they came in and they signed, and they came in and got their materials. They registered for. We had 9 door prizes, plus we had some books that were copies of the door prizes that we were able to give to the library, so everybody could enjoy them if they didn't win a door prize. So you could win a prize coming in the door if you brought your sheet. We had 9 door prizes. We had the estimation jar full of M&Ms that you could win. And then we had the graphing activity that was a way of attendance. And for the class that had the most number of students there, that whole class got a prize whether everybody in the class was there or not. This year we had a tie in 4th grade, Mr. Archer's class and Mrs. Crackle's class tied with the most number of students, and then Mr. Polak's class in 5th grade. So they all got animal erasers. You know, tried to keep it to a science theme.
Yeah.
Okay.
Now, how many M&Ms were in the jar?
Oh, I didn't do the jar this year. I believe, I can't even begin. Close to 900 and change. The jar is really difficult, and we don't let them touch it. This year, I farmed that job out. We kind of do that. When we do a family science night, I might be the person to do the estimation jar and the door prizes because I'm not the one up in front by the mic. We kind of take turns who does what.
So, did a student win the?
A student won.
Do you know what student won?
Yeah, Jenna Wiley won the estimation jar. She's a 4th grader in Mrs. Kitely's room.
All right, thank you for coming in, Mrs.
You're
Claus.
welcome.
All right, this has been another segment of Real TV. Thank you.
4th annual Kroll Family Science Night. And we're going to, I can guarantee you, we're going to have a good time tonight. We practiced this experiment this afternoon. Anybody who lives in the neighborhood and didn't hear us laughing hysterically as we held our sides, I don't know, you must have been at work and out of the neighborhood, because Mrs. Geiser, Mrs. White, and Mrs. Spiegler and I, we all tried it this afternoon, made sure it was going to work, and we had way too much fun. All I can tell you is it's very, very noisy. That's all I can assure you. It's a noisy experiment. The children will love it. Now, what I want to do first is, one of the things that we always get a comment is, we need more door prizes. So I'm going to start with door prizes, and instead of giving them 1 at a time this year, we're going to give 2 at a time. Hey, we doubled it. What do you want? I mean, we're doing pretty good here. If you have not done the estimation jar, please go back to Mrs. White and do so now so she can count the estimates while we're doing the experiment. If you would do that, please. And I want to say thank you to Mrs. Shelley Kitely in her enrichment class for our PowerPoint presentation that's on the TVs tonight for MEEP test taking skills. Mrs. Kitely. All right, if you'd open your packet, please, and take out your science journal and a pencil. And you've got 2 straws, a pair of scissors, and a marker. Now, if you have more people in your party than 2, please raise your hand, and we will try and get you an extra straw. Everybody should have a straw. This is way too much fun to miss. Raise your hand. You've got a science journal that looks like this. Okay, everybody got their science journal. I am going to put up the question that we are going to investigate. And I'm going to put it up nice and big so everybody can see it. And you're going to copy that right on the Science Journal. This is what your students will be doing for the meet when it starts on the 21st if you have a 5th grader. And just so you know, this is last year's 5th grade meat experiment. And they allowed us to do this. So if you had a 5th grader last year, anybody here have a 5th grader last year? Aha, this is what they did. And here's your question. If you would copy it on the lines and it says, can a straw be altered so that it will produce a sound? And can the pitch of the sound be affected by the length of the straw? If you would copy that in number 1 on your Science Journal, please. Your students should be able to handle this, I think. Mom and Dad, you're welcome to do it, but they should be able to handle this. She can move up here if she wants.
I don't want
I have someone here who just told me he already knows the answer to this because he saw it on Zoom. Can a straw be altered so it will produce a sound? And can the pitch of the sound be affected by the length of the straw? Andy's just dying to tell us the answer. We'll let you in a minute. Can a straw be altered so that it will produce a sound? And can the pitch of the sound be affected by the length of the straw? Oh, okay. Can a straw be altered so that it will produce a sound? And can the pitch of the sound be affected by the length of the straw? Okay?
Should have been that way.
Wow. What?
You're double generating.
Let's go back up to where we were. And it says what I already know about this. I got a bunch of boys up here dying to tell me. Andy, what do you know about this? Can we change the straw and change its sound?
Yes, you can. By
What are we going to do with the straw?
You flatten one end, but then you kind of open it up. And then while you're blowing on it, it's like one of those, I forget what they're called. They're these long things. Yeah. And the only thing, when you cut the end of the straw, it changes its sound, but one thing, it sounds awful.
Oh, it does. Anybody else want to tell us what they think? Mrs. Geis, you got anybody back there? Anybody else? What do you know about this? Nobody. Mr. Grant, what do you know about this? No, I didn't. Joey. Joey, you. No. I knew you. I heard you talking. What do you want to say? Anything? Yeah. You know.
That it will be a higher pitch if we cut it, or a lower, something like that, or higher if we just leave it, or lower. So, I think it's going to be lower when we cut it, higher, and higher if we don't cut it.
All right. Take a minute, talk with your student, and decide what you know about this straw as we make it shorter. What's going to happen? Talk with them for a second.
Give it a haircut.
When you pass your discussion, if you would put that right here where it says what I already know about this, what do you think is going to happen? What do you know about this, about blowing through a straw? As you're having this discussion, I want to share with you what the state curriculum standards say. We are testing for 3 things. We are looking for the student's ability to develop solutions to unfamiliar problems through reasoning, observation, and/or experiments. We're going to develop the need for evidence in making decisions scientifically. And what we're really, and those are objectives that are everywhere in the curriculum. And then specifically we're working on the described sounds in terms of pitch and volume.
When you take this, if you've never done this, and you don't know anything about it, and you have this straw, what do you know about the straw?
It's a straw. It's made of plastic. Round. It's clear.
It's bare.
I can see through it. No, it's a cylinder.
Shall we move on to what I think will happen?
Right, just
Otherwise known as our, what do we call this? Our adjacent, Adele, what do we call this? Our hypothesis.
It helps. She's writing something down. Maybe I'll cut it like this.
What do you know about the straw? I'm looking at the straw, not what you know it's going to do. Pretend you've never done the experiment.
Decide with your student what you think is going to happen. Will the longer straw be higher pitch or lower pitch? Decide what you think and write your hypothesis. I'm going to write mine here, and you're welcome to share mine if you like.
I don't either. Longer strawberry. I know what you're supposed to do. So you cut it like that, you cut it like that.
I know, but thinking about beef stuff hugely, we could get all
It's like a...
people are hugely, they're super strong, super strong. They come back, they get super powerful guys. And that's nice.
Alright, so I'm taking one of the thing.
And you get like all the stuff.
Internet and Oval.
You may borrow mine if you, mine is, I think that the shorter the straw, the higher the pitch. That's going to be my hypothesis.
We do cut it.
Parents, just so you know, these science journals are the ones we use at Crawl, but when your fifth grader takes the MEAP, they are going to have their materials already provided for them, a materials list. But when we do a science demonstration or a science experiment here, they would list their materials. But in the MEAP science journal that they get from the state, it's given to them. But so you know when it's time for science fair, you're going to need to go through that step of materials. Okay? And now I'm going to put the directions up here. I'm going to call on our drummer to help me, simply because this is a very loud experiment at some point in time. And as we go through, what's going to happen is we kind of need to stay together on this. Mrs. Trask, we did this last year, and she knows everybody's going to have to kind of stay together, because what happens if you start cutting and making noise over here, people over here aren't going to be able to figure out what's going on. So if you've already cut your straw 3 times and they're still over here on the longest sound, it's going to be really hard to figure out what's happening. What I did last year in the classroom was I used the lights as a cue. And so we turn out the lights. Okay, everybody try it. Turn the lights back on, cut the straw, turn out the lights, try it again. We're going to use a drum roll tonight just to kind of keep this as organized chaos. Are you ready? I'm going to put some directions up there. Unwrap, gentlemen and ladies, unwrap your straws. Step number 1. Take your straw, and it says, flatten one end of the drinking straw, creasing the side so it will stay flat. You may use your scissors, the side of your scissors to flatten your straw. You may use your fingernail on the table. I used my teeth, but my dentist would not recommend that, so I'm not going to recommend it, but that's what worked for me. So whatever you have to do to get that straw end flat, nice and flat. Okay. The next set of directions say, use the scissors to trim a little from each side so that it can be shaped to form a reed. And if you look right here, they kind of notched it on either end to make the reed end. What we're doing is trying to make a reed instrument. And I'm going to tell you right now that until you blow in it for a while and you get some moisture in there, like you do with a reed when you play the saxophone, right? It's not going to work. So if you tell me the first time you try it, it doesn't work, blow in it for a while. It'll get better. Somebody's got it. Come on up here, Mrs. Fiedler. All right, Mrs. Fiedler, you can demonstrate now. All right, guys, make it work. from the MEAP office every year. Take your ruler and lay it so that the zero end starts at the end of the straw that is not cut. Put it at the round end. Match the uncut end of the straw with the zero end of your ruler. Okay. Now, take your marker and mark on your straw. And these markers are, they may rub off, so try and, they're not permanent markers. Mark your magic marker. Use it at 3 centimeters apart. So you're going to have lines at 3, 6, 9, and 12 on the straw. 3, 6, 9, and 12. You should have 4 lines across your straw at 3, 6, 9, and 12.
Why doesn't work? Yeah, but it doesn't work it.
We're looking right here. If you see where I am, where my finger is pointing, your straw should look like this. The round end, you're going to measure at 3, 6, 9, and 12. And remember, if your 5th grader can do this, you can do this. And we've already done our test sound, so here comes the next thing. You are going to need to snip your straw at the 3 centimeter mark. Do not start doing it, just snip it, and then when I say go, we'll all give it a try and see what happens, because your straw will be 3 centimeters shorter than it was when we did our first test. Are you ready? Are we all snipped? No, we're not all snipped. Wait a minute. Our scissors are courtesy of our art department.
Too sharp.
All right, are we ready to give our first try? On your mark, get set, try it, go.
Higher.
Your straw was higher. Lee, what's your straw? Right here, raise your hand. Your straw is what?
Higher.
Okay, Heather.
Your head hurts after a while. Higher or lower? Mine was higher.
Let's rest our straws for a moment. Where's Mrs. Stoutenberg? It's Vanna time.
It works for everybody else.
We need a break.
Mine doesn't.
I don't want anybody to get winded here. Wonderful experiment for the millennium. Yes, we're all using our Happy New Year's horns. All right? For the last, yes, Michelle. Okay. Time, cut. To cut again. All right? Cut again.
I can't cut my hair. This needs to be a while.
Try your experiment again. Put them in your pocket and take them home. So,
Now you hit it.
we have cut our straw 3 times, and we are down to the shortest one. And what does our straw sound like now? Mary Ann Huddy, what's going on? My neighbors hate it when what's going on, Mary Ann? How's your straw sound?
It's higher.
It's higher pitch than it was when we started. Anybody else want to share? Right over there. Tori wants to talk. So is that higher or lower, Tori?
Higher.
Higher. All right. Time to place your instruments down or put them in your pockets to take them home. And we need to move on to our conclusion. Our conclusion is right here. What can we say our conclusion is? Who's got a good conclusion that we can put up here? Who's got one to share? Laura. Go ahead, Laura. Tell us what you think. What happened? I can't hear you, dear. Use your outdoor voice.
The pitch got higher as we cut it down.
The pitch got higher as we cut the straw shorter. And our hypothesis, my hypothesis was that I thought the shorter the straw, the higher the pitch. So my conclusion will be, yes, The shorter the straw, the higher the pitch. Please put your conclusion, and then I'm going to come back up to the drawings and charts. But let's get our conclusion done. I have my conclusion up there that says, the more I cut the straw, the higher the pitch. I'm going to put up a couple of examples of what we used last year for the drawings, charts, tables, and graphs. Other ways to record your observations. On the bottom of page 1 of your science journal, there's a place to record your observation notes. And you can list exactly what we did as we went through. But I'm going to put up a couple of things we did with our 5th graders last year to represent what we did. This one says the length of the air tube, better known as the straw. It was originally at 19.5 centimeters. That was the lowest. And then we worked our way through, and that's where you could put your results, your observations. Here's one way to represent it, and they put it in a chart. And here it says the length of the straw and the pitch. That's one way that you could represent that on that top of page 2 in your journal. Another way to represent it would be this way. This is a bar graph, and I want to point out to you that I have used these squiggly lines, and that may not look like what parents are used to seeing as a bar graph, but in the new math series that we're using at Kroll, that is how they represent. They don't shade it in completely. They are using these lines in the new math series. And what I did is I made a line that, I made a graph. I'm terrible at these. I shouldn't, it's a good thing I wasn't a dentist. Down here on this axis I have pitch. On here I have straw length, the lowest, and there it went, and it went all the way to the top, and here's how I did that. That's one way to do that. You could do it as a graph that way. I have one more way. And the third way would be this way. Here's my air tube, here's my pitch, and we did a line.
I got condensation.
While you're What I wanted to point out to you, boys and girls, when you do a science fair project, how many times, what's the least amount of times you're supposed to repeat your experiment? Put your fingers in the air. How many fingers? Oh, look at this. Everybody knows it's supposed to be 3. Well, let me ask you, how many times did we perform this experiment tonight? How many people are in this room? We performed it 3 times. How many people are in this room? We had 125 people registered. So if that's an accurate count, we all did this experiment 125 times. And I think we kind of agreed that the shorter the straw, the higher the pitch. So we have a great deal of data to use for our experiment. So you know that 3 is the minimum. Tonight we had everybody's opportunity, everybody's chance to give it a shot. So we have a lot of data to work with. And comes the fun part. What could we have done wrong? What were the things we could have caused errors in our investigation? Blowing the wrong end of the straw. Yeah, that'll do it. What else could we have done wrong that would have messed up our investigation? Jerry Ann. Mrs. Geiser, I can't hear Jerry Ann. Jerry Ann, what could you have done?
You could have cut it the straw into strips.
Could have cut the straw wrong. That'll do it. Could have what?
Measured it wrong.
Measured it wrong. That'll do. Mrs. Geiser's getting her aerobics workout. What else?
How much air you blew through it?
How much air you blew through it. Sometimes we have a little trouble getting that reed put together.
Much moisture?
Too much moisture. I suppose that hasn't happened to me, but that doesn't mean it wouldn't. Mine was the other problem. Mr. Tynan,
How fast you blow the straw?
how fast you blew through the straw. What else could we have done? You got one over here. Oh, go ahead and get Tori's.
It's the goodest time I ever had.
What, doing this experiment, Mr. Paul? Oh, Mr. Pollack was bad last year. He didn't follow directions.
You might have split the straw, planning at the end.
You could have split the straw. Jake? Pardon?
You couldn't flatten it all?
You couldn't flatten it, that's a possibility. Okay, one more. Michael, did you get yours? Did you get your part? Okay. All right, take a minute and record some of your errors and